So let's talk about anatomy of memory. So when we talk about anatomy of memory, we have the kernel at the top and we've got text at the bottom. So if you think of your kernel, think of your command line. You can also think about this as a bunch of ones. And your text, you can think about as your read-only code, and you can think about that as a bunch of zeros. So this is only for informational purposes, but we can also call this the kernel the top, the text the bottom. Where we're really going to be focused on, though, is going to be the stack. So if we dive into this memory here and we dive even deeper and we go into the stack, it's kind of similar. So we have these registers here, and I'll provide links down below on how to brush up on some of these registers if you're not familiar. But the important things, what we need to know for this lesson, is that you have the ESP, you have your buffer space, your EBP, and your EIP. So we can think about this again as the ESP sitting at the top and the EBP sitting as the bottom. So what happens is you have this buffer space, and this buffer space fills up with characters. So the buffer space is going to go downward. What should happen is if you're properly sanitizing your buffer space, then if you send a bunch of characters at it, say a bunch of A's, for example, like this, you should reach the EBP but stop. The buffer space should be able to contain the characters that you're sending. Now, however, if you have a buffer overflow attack, then you actually overflow the buffer space you're using and reach over the EBP and into something called the EIP. Now, the EIP is where things get interesting. This is a pointer address or a return address. So what we can do is we can use this address to point to directions that we instruct. Now, these directions are actually going to be malicious code that gives us a reverse shell. So we're going to learn that later on in future videos as we go step by step. So this doesn't have to seem very logical right now. You just have to very, very base level understand that what's happening in the stack is that you're overflowing buffer space. So if you can write over the buffer space and write down all the way to the EIP, you can control the stack and you can control the pointer, and eventually you can have a reverse shell, which will lead to root. So it's going to make a lot more sense when we dive into hands-on. This is just more of a theoretical thing. So let's talk about really quick the steps to conduct a buffer overflow. So the first step we're going to cover is called spiking. So spiking is going to be a method that we use to find a vulnerable part of a program. Once we find the vulnerable part of the program, we're going to do fuzzing, which is kind of similar to spiking. So fuzzing, we're going to send a bunch of characters at a program and see if we can break it. If we do break it, we want to find out at what point we did break it, right? So we want to find something called the offset, and we use that offset to overwrite the EIP, that pointer address that we were talking about. Once we have the EIP controlled, we need to do a few house cleanup things. One is called finding bad characters. The other is called finding the right module. This doesn't need to make sense right now. But once we do that, and we have this information from steps 5 and 6, we can generate shellcode, this malicious shellcode that will allow us to get this reverse shell. So we're going to use that. We're going to point that EIP to our malicious shellcode, and hopefully we're going to gain root. So again, this will all make sense as we dive into the future videos and we get hands-on. So if you look at these videos, these are the videos that are going to come. So our next video is going to be on spiking, second one's going to be on fuzzing, and so on. So if you have trouble with one area in particular, you can watch that area specifically and not have to look through a long video and hopefully break this down into little nuggets.